Okay, so this is version 1 of test 1. All right, and so the first problem, you had to solve this linear equation. And notice that in this linear equation, you have three sets of parentheses. And notice that in each of these parentheses, these expressions that's inside these parentheses is being multiplied by numbers. So this one is being multiplied by 4. This expression is being multiplied by 2. And then this expression is being multiplied by 5, not 8. So it was mathematically incorrect to have said 3 plus 5 is 8 and then distribute the 8. So remember, order of operations says you have to multiply first before you add. All right, so that was something you had to be aware of here. Okay, so in each of these cases, though, you want to get rid of the parentheses, and we're going to do that by using the distributive property. And so when I use the distributive property, I get 4 times 2x is 8x. 4 times a negative 3 is a negative 12. A positive 2 times 3x is 6x. And a positive 2 times a positive 1 is a positive 2. So on the left-hand side, these two sets of expressions here, I can rewrite as these four terms. On this side, remember what we just talked about, you must, order of operations, you multiply before you add, so you have to distribute the 5 first. And so this becomes 3, and then 5 times x is a positive 5x, and then 5 times a negative 2 is a negative 10. All right, so that was your next step. Then what we're going to do now is to combine like terms. So remember, you must show all steps. So skip any steps, you're not going to get your full points. All right, when I combine like terms, I have 8x and 6x. Those are like terms. So remember, terms are like terms are terms that have the same variables raised to the same power. So both of these terms here, 8x and 6x, x is both being raised to the first power. So I can combine those. So 8x and 6x is going to be 14x. So I get 14x. And then these constants, remember a constant is a numerical expression, not a variable expression. So notice there's no variable here, so that's a constant. A negative 12 and a positive 2 is a negative 10. Now remember, you had access to a scientific calculator, so you could have used your calculator with this. So let me see if I can move this to a certain way. So let me do it right here. All right, so remember your negative button's right here. So negative 12 plus positive 2 is a negative 10. Okay, equal. And on this side, the 5x is the only term involving the variable, so I'm going to rewrite it first. And then the constants, 3 and a negative 10 is a negative 7. Again, use your calculator if you need to. All right, now the next step is to bring all the variables to one side, constants to the other. So I'm going to bring all the variables to the left-hand side. It did not matter. You could have brought the variables to the right-hand side, constants to the other. Does not matter. So to do that, I'm going to have to subtract 5x. Remember, you want a 0 here. So if you added 5x to both sides, that would not have helped you because 5x plus 5x is 10x. So you want to do the opposite here. So you want this to be a 0. So this is a positive 5x. You're going to subtract 5x from both sides. What you do to one side, you do to the other. Notice I'm aligning my like terms, so that will help. 14x minus 5x is going to be 9x. I get 9x minus 10 equal, this is 0, that's what we wanted, and then 0 and a negative 7 is a negative 7. Then the next step is to get that 9x by itself. So right now I'm subtracting 10. The opposite is to add 10 to both sides. So you want to bring the constant to the right-hand side. Combining like terms, notice I'm aligning my like terms, so now I'm going to combine them. A negative 10 and a positive 10 is 0. 9x plus 0 is 9x, equal. And then a negative 7 plus 10 is a positive 3. And then to get x by itself, let me go ahead and just rewrite this over. So to get x by itself, remember right now I'm multiplying x by 9. The opposite of multiplication is division. So I'm going to divide both sides by that coefficient of x. You must divide by 9. Don't divide by 9x. That's incorrect. You have to divide by the coefficient only. And so 9 divided by 9 is 1. 1 times x is x. And so I'm going to go ahead and write this here. So I get x is equal to, and then you reduce. So 3/9 is 1/3. All right, so notice the work you have to show to get all your points. Missing any of these steps, you're not going to get all your points. Okay, number 2, we have this linear equation still. And so notice, though, I have like 2 fractions, right? Although you could break it down and you would get more fractions, but I would leave it like this. So I'd leave it as where you're subtracting these 2 rational expressions right here. Now, what you want to do is that since you have denominators here, unlike here, now you could think of all this as being divided by 1, by the way, but notice that I do have denominators other than 1. And so what you want to do is you want to clear those fractions. And so we're going to clear those fractions by finding the least common denominator. And so the smallest number that 2, 3, and 2 will go into is 6. Now, once you find the least common denominator, we're going to multiply both sides by that least common denominator. So I'm going to go ahead and rewrite this left-hand side over. So we have 3x minus 1 divided by 2 minus x plus 5 divided by 3 equal 1/2. And so I'm going to multiply both sides by 6. Now notice I'm enclosing the left-hand side in brackets or parentheses. I'm going to use brackets here because I have more than one fraction. So I'm going to say times 6 and then times 6 here. Now, just like we did in the previous problem, I've now got to get rid of that bracket. So I'm going to use a distributive property again. So just like this. So this becomes 6 times 3x minus 1 divided by 2 minus 6 times this fraction. So 6 times x plus 5 divided by 3 equals 1/2 times 6. All right, now remember the whole point of multiplying both sides by the LCD is to get these fractions now to be factors of 1. And now I can, because 2 divided by 2 is 1, 6 divided by 2 is 3. 3 divided by 3 is 1, 6 divided by 3 is 2. 2 divided by 2 is 1, 6 divided by 2 is 3. And I'm going to read, now notice all these denominators now have factors of 1. So my next step is going to be an equation without any fractions that we saw earlier. So this becomes 3. Now you need to put this in parentheses because this 3 is going to be multiplied by each of these terms here, or each of those terms will be multiplied by 3. So do this. You have to say 3 times 3x minus 1 minus 2 times x plus 5 equals, and then 1 divided by 1 is 1, times 3 is 3. And so now this kind of looks like number 1. And so we can use the distributive property again in both situations. And so I get 3 times 3x is 9x. 3 times a negative 1 is a negative 3. A negative 2 times x is a negative 2x. And a negative 2 times a positive 5 is a negative 10, and that equals 3. Combining like terms, 9x and a negative 2x is 7x. Then your constants, a negative 3 and a negative 10 is a negative 13, and that equals 3. Getting the variable, getting the term 7x by itself, right now I'm subtracting 13, the opposite is to add 13. And then combining like terms, 13 negative 13 is 0, so I get 7x and 0, 7x equal, and then 13 plus 3 is 16. And now, I'm going to go ahead and just rewrite this over. Okay, so now to get x by itself, right now multiplying x by 7, the opposite of multiplication is division. Divide only by 7, not 7x. 7 divided by 7 is 1. 1 times x is x. I get x to be 16 sevenths. And then it cannot be reduced, but if you want to, you can write this as a mixed number. So remember how to do that. You're going to 7 into 16. So 7 goes into 16 2 times. 2 times 7 is 14. Subtract, you get 2. And so you get 2 and 2 sevenths. So 2 and 2 sevenths. So either one's fine. But notice the work you have to show. All right, so show work to get all your points. All right, so that was number 2. Now number 3, we have this rational equation this time. And so notice that in this rational equation, you have variables in the denominator. And so to clear those fractions, to clear the fractions here, we have to find the least common denominator, just like the previous one, except this time my least common denominator is going to involve variable expressions. And we also need to find the restrictions at some point as well. All right, so notice that, and to find the least common denominator, we've got to factor each of those denominators. Now, x plus 2 is a linear factor, and the GCF here is 1, so it cannot be factored. And so to find the least common denominator, you have to include every factor in the denominator has to be in the LCD. So this factor x plus 2, I have to include it. Notice I'm putting that in parentheses. Now remember, the least common denominator is a product, a multiplication is a product of all these factors. Don't separate those by commas, because that's not what the LCD is. So it's a product. So you're going to say x plus 2 times, and then you see this x minus 3. I cannot factor that any further, so that's going to become x minus 3 just like this. And then over here, this is a quadratic expression here, and so we need to factor this. Now usually what happens is that to factor this, you're going to use, that's not always the case though, but usually check and see if the factors of this quadratic expression are actually these. And it is. So when you factor this, you actually get x plus 2 times x minus 3. So that's how this can be factored. And then notice that x plus 2 is already included. Don't list it again. Don't list it again, because that's no longer the least. It's a common denominator, but it's not the least. You want the least to make things easier on yourself. And then x minus 3 is already listed. So there's your least common denominator. Now the restrictions is the values for x for which the denominator is 0, or for which the rational expression is undefined. So if we look at x plus 2, you're going to ask yourself, and let me go ahead and actually do it here. So you're going to ask yourself, where is x plus 2 equal to 0? Well, x plus 2 is equal to 0 when x equals negative 2. So that's going to be one of your restrictions. So one of your restrictions is that x cannot equal negative 2, because when x equals negative 2, the denominator is 0, and 2 divided by 0 is undefined. So your restriction is that x cannot equal negative 2. The other restriction is, where is this 0? Well, x minus 3 is equal to 0 when x equals 3. So there's the other restriction, x cannot equal 3. Then you go to the next one, x plus 2, we already dealt with that. So that's 0 when x is negative 2. And then x minus 3 is 0 when x equals 3. So there's only two restrictions. And you can really get the restrictions by looking at these factors here. There's only two factors. You're going to see two restrictions, as long as those factors are different. Okay, now, so we're at that point now. So now what we're going to do, just like in the previous problem, is we're going to multiply both sides by the least common denominator. So I'm going to go ahead and rewrite this over. So I have 2 divided by x plus 2 plus 5 divided by x minus 3 equal, and then 6 divided by, and I'm going to go ahead and factor this, x plus 2 times x minus 3. Okay, so now I'm going to enclose this in brackets just like I did the previous problem. And I'm going to multiply both sides by the least common denominator. So the least common denominator is x plus 2 times x minus 3. So x plus 2, x minus 3. Okay, now I'm going to distribute. Use the distributive property. So when I do that, I get at least common denominator times this fraction. So you're going to say x plus 2 times x minus 3 times 2 divided by x plus 2 plus, and then the same thing here. So the least common denominator, which is x plus 2 times x minus 3 times that second fraction. Now I'm running out of room here, so I'm going to just go ahead and reduce these right here. So remember, the whole point of multiplying both sides by the least common denominator is to get these to be all factors of 1s. And so when I do that, you'll see that x plus 2 divides to x plus 2. You get factors of 1. X minus 3 divides into x minus 3 as well. And so notice 6 divided, see 1 times 1 is 1. So 6 divided by 1 is 1. 1 times 1 is 1. So 6 times 1 is 6. So you get 6 there. Now let's go ahead and reduce the left-hand side. So the x plus 2's divide out. You're left with factors of 1. the x minus 3's divide out, we're left with factors of 1. So now we're going to rewrite this equation without those denominators. So we're going to say, now notice that what you see here is 1 times x minus 3 times 2. This is 2 right here. 2 divided by 1 is 2. Remember, multiplication is commutative. So you have three things being multiplied together. Multiplication is commutative. The order in which you multiply does not matter. So I'm going to say this. 1 times 2 is 2, and then we're going to multiply this 2 by x minus 3. So that's going to look like this. Plus, same thing here. X plus 2 times 1 times 5. 5 times 1 is 5. We're going to multiply 5 by x plus 2. This is x plus 2. So 5 times x plus 2 equal 6. And now we're going to go ahead. So notice now I have an equation, a linear equation. So I went from a rational equation to a linear equation without any fractions. And so now we're going to just use the distributive property. And when I do that, I get 2 times x is 2x. 2 times a negative 3 is a negative 6. 5 times x is 5x. And then 5 times 2 is 10 equal 6. Combining like terms, 2x and 5x is 7x. A negative 6 and a positive 10 is a positive 4 equal 6. Subtract 4 from both sides. I'm going to get 7x equal 6 subtract 4 is 2. Remember, negative 4 is 0. And then remember, to get x by itself, we're now going to divide both sides by 7 because I'm multiplying x by 7. So we're going to divide both sides by the coefficient. 7 divided by 7 is 1. 1 times x is x. So x equals 2 sevenths. Now remember, 2 sevenths is a solution to this linear equation. But the question is it a solution to this rational equation? A rational equation with variables in the denominator. And really all you have to do is just check those restrictions. So you did have to go back and verify that this solution, which is a solution to this linear equation, you need to verify if it is a solution to this rational equation by checking the restrictions. And so notice that my restrictions are negative 2 and 3, which is not 2 sevenths. So 2 sevenths is a solution. So you could have had, the problem could have had x equal, let's say, 3, right? And so if this was a 3 right here, you would have noticed, well, if this was a 3, that would mean that 3 is a solution to this linear equation, but it's not a solution to the original, to this rational equation, because 3 would be a restriction. So you would say no solution, and you've had problems like that before. Okay, but in this case, 2 sevenths is a solution. All right, so that was number 3. Okay, number 4, we have this quadratic equation. We have this quadratic equation, and the directions said solve this quadratic equation by using the square root property. So you have to use the square root property. You have to follow directions. So I'm going to go ahead and rewrite this over. So I get 3x minus 5 squared equal a negative 16. And so you want to solve for x, but notice that this binomial here, this binomial expression, 3x minus 5, is being squared. So I got to get rid of the square. The opposite of squaring is to take the square root of both sides. And remember, though, when you take the square root of both sides of an equation, you have to remember that plus or minus. And so the square and the square root undo each other. So your variable expression that's left here is 3x minus 5 equal plus or minus. And then you have to remember the square root of a negative 16. So remember, the square root of a negative 1 is defined to be I. So you can have imaginary solutions here. And so therefore the square root of a negative 16 would be the square root of a negative 1 times the square root of 16. Well, the square root of a negative 1 is I. Square root of 16. 16 is a perfect square. Square root of 16 is 4, so this becomes 4i. And so this right here then would become plus or minus 4i. Now, since my solutions are going to be imaginary, the best way to rewrite this, which we've talked about, is to put this in compact form, meaning that to quickly solve for x, all you have to do is add 5 to both sides, just like this. And when we rewrite this, we're going to get 3x is equal to 5, positive 5, plus or minus 4i. Now, don't make the mistake and say 5 plus 4i is 9i. That's not true, because 5 does not have that imaginary unit. Okay, only this term does. So those are not like terms. All right, so we get this, and then to get x by itself, you divide both sides by 3, and you're done. So most students would write it as 5 plus or minus 4i divided by 3. That's the way most students would write this. Now, you could write them separately because you do have two distinct solutions here. One is 5 plus 4i divided by 3. Make sure it's all divided by 3. And the other is 5 minus 4i divided by 3. So any one of those is fine. But there's the work. There's your solution. Number 5, you want to solve this quadratic equation by factoring. Now, to solve this quadratic equation by factoring, you had to put this in standard form, meaning you had to have 0 on that other side, and we needed to put it in descending order. So to do that, we're going to rewrite this as 3x squared plus 10x minus 8 equals 0. And now we're going to go ahead and factor this. So the GCF is 1 here, so we're going to go and factor this as the product of two binomials. And 3x squared, so 3 is a prime number, so that part's easy. So that's going to be 3x and x. So one's going to be 3x, the other's going to be x. Okay, now notice that now you got to find out, remember this is trial and error that we're using. The next thing you have to do is figure out, well, what number times what number is going to be a negative 8, so that way when you check this, you get a positive 10x as your middle term. And so what's going to work is that this needs to be a 4 and this needs to be a 2. That's what's going to work. And then the last sign's negative. That means that these signs in here are going to be different. One's going to be positive, one's going to be negative. And what's going to work is that this has to be a positive 4 and this has to be a negative 10. And you can check. So when you check this, and so it's always a good idea to check. When you check this, when you multiply it out using FOIL, or the distributive property, you're going to get 3x times x is 3x squared. The outer is 3x times 4 is 12x. The inner, negative 2 times x is negative 2x. And the last, negative 2 times 4 is a negative 8. Combining like terms, we get 3x squared. 12x minus 2x is positive 10x, and then minus 8. And notice that this is this. Okay, now the next step, so I had to see this right here. And so the next step is to use a zero factor property. So you have to set each factor equal to 0. So you would say 3x minus 2 equals 0, x plus 4 equals 0. So remember, when you have two or more factors whose product is 0, then one of those has to be 0. That's the only way you can get a product is of 0. And then notice I went from a quadratic equation to two linear. So let's solve these linear equations. So I get 3x equal 2. And then divide both sides by 3. One of my solutions is 2/3. The other one, subtract 4 from both sides. I get x equal negative 4 is the other. So those are your two solutions. Okay, number 6. In number 6, you want to solve this quadratic equation using the quadratic formula. So remember, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac. So b squared minus 4ac has to be inside the square root symbol. All of that, notice from here to here, is being divided by 2a. And so this is already in standard form, so 0 is already in the other side. So all you had, and it's in descending order. So all you had to do, first of all, is determine a, b, and c. So what's a, what's b, what's c? Well, remember, a is a coefficient of x squared, so a is 2. B is a coefficient of x, so that's a positive 4. And c is your constant, so that is a negative 3. And now we're going to take all these values for a, b, and c, substitute into the formula. So I get x equal, remember this says the opposite of b. Well, b is a positive 4, so the opposite of a positive 4 is a negative 4. Plus or minus the square root of, and then b squared, so I'm going to take b, put that in parentheses, and I'm going to square it. Now remember, b squared should never be negative. It should always be either positive or 0. Minus 4 times a is 2, times c, which is a negative 3. All of that, so I had to go from here to here. So I'll be looking to see how you wrote this. from here to here is being divided by 2 times a, so that's 2 times 2 because a is 2 here. Now let's go ahead and simplify the discriminant, because remember in the quadratic formula this is the discriminant. In general though, when you have a radical, we refer to this as a radicand. Alright, so let's go ahead and simplify the radicand, or the discriminant in this case. And so we have 4 squared 16. So you're going to say negative 4 plus or minus the square root of 16. And a negative, negative 4 times 2 times a negative 3. So negative 4 times 2 is a negative 8. A negative 8 times a negative 3 is a positive 24. All divided by 2 times 2 is 4. Equal negative 4 plus or minus the square root of 16 plus 24 is 40. All divided by 4. Okay, now, remember you're going to have to simplify the radicals if you can. So let's look at the square root of 40. So if I look at the square root of 40, the largest perfect square that goes into 40 is 4. So that means I can simplify this. So I get the square root of 4 times the square root of 10. 4 times 10 is 40. And 4 is a perfect square, so the square root of 4 is 2, so this becomes 2 square root of 10. And so now I'm going to rewrite this as negative 4 plus or minus 2 square root of 10 divided by 4. And then I want you to notice that this negative 4, this positive 2, and this 4 are all divisible by 2, so I can simplify this further. So this is going to equal negative 4 divided by 2 is a negative 2, plus or minus 2 divided by 2 is 1. 1 times square root of 10 is square root of 10. All divided by, and then 4 divided by 2 is 2. All right, so that was it. Number 7, you wanted to solve this polynomial equation. Notice you have 4 terms. It is in standard form. You have 0 on the other side, and we're going to do this by factor by grouping. And so what usually works, not always the case, but what usually works, and what you want to try first, is to group the first 2 and the last 2. And so when I group the first 2, notice the GCF, the greatest common factor of that first group, is x squared. So I'm going to rewrite this as x squared times, and then we're going to rewrite this expression as a product here. So x squared times 2x is 2x cubed. X squared times a negative 3, x squared times negative 3 is a negative 3x. So that's how you get to do this one. So this binomial right here, these two terms, I can write as this product. Over here, if you look at positive 12x and a negative 18, the GCF is 6. 6 goes into 12x, 6 goes into negative 18 evenly. So we're going to factor out this positive 6 though. So plus 6 times 2x minus 3. And then that's going to equal 0. Now, if this is being done correctly, in other words, if this equation here, this expression that's on the left-hand side, if it is factorable by grouping, then you're going to notice that in these two groups here, you're going to have a common factor. And in this case, we do. So now what we're going to do is we're going to factor out that common factor. So you're going to say 2x minus 3 times x squared plus 6. So you have to show that. And so in some of your worksheets that you had to do, some of you forgot to do that. So hopefully you looked at your worksheets and you remembered not to make this mistake. So you had to show this. And now, just like the previous problem, we have two factors whose product is 0. So one of them has to be 0. So we're going to set each one equal to 0. So I get 2x minus 3 equals 0. And then x squared plus 6 equals 0. Notice I went from this cubic equation to a linear and a quadratic. This linear equation is easy to solve. We're going to add 3 to both sides. And so I get 2x equals 3. Then divide both sides by 2. One of my solutions is 3 halves. Over here, the best way to solve this quadratic equation, you could have used the quadratic formula, but the best way to solve this, since there's no x term, is to bring 6 to the other side. So I get x squared equal negative 6. And then let me go ahead and rewrite this over. And so then to get x by itself, you're going to do the opposite of squaring. The opposite of squaring is square root, just like this, plus or minus. Don't forget that plus or minus. So when you take the square root of both sides, or the even root of both sides, you're always going to have that plus and minus symbol there. The square and the square root undo each other, so get x equal plus or minus. Now, let's simplify the square root of a negative 6. So the square root of a negative 6, I can write as the square root of a negative 1 times the square root of 6. The square root of a negative 1 is I, so we have that I being involved here, an imaginary unit. The only perfect square that goes into 6 is 1, so that means the square root of 6 I cannot simplify. So leave your answer like that. So this becomes plus or minus I square root of 6. Okay. Now let me warn you about something, and hopefully you didn't do this because we talked about this before. So this square root of 6 here, where it had I square root of 6. Some students like to put I in back of that radical. Well, that's fine as long as it looks like this. Square root of 6 I. Notice that I is not supposed to be under the square root. I is supposed to be outside. So if you put it outside and it looks like this, plus or minus the square root of 6I, that's not correct. You are going to lose points because I is not supposed to be under the square root. That's why many students, when they have a radical and an imaginary unit, they always put that I in front so that way there's no mistaking where that I is. All right, so be careful if you put it in the back, like, because this would be incorrect and you would not get all your points, even though you meant this. How you write things mathematically means some importance as well. Okay, so that's number 7. Number 8. So number 8, you have this square root equation, and to solve the square root equation, to solve each of these square root equations here, and there are 2 of them, to solve each of those, we need to get that square root by itself. And so we're going to, first of all, have to subtract 2 from both sides. So I get the square root of 3x minus 5 is equal to, and then 5 subtract 2 is 3. So that's your next step. So you have to show that. Now, once you have the square root by itself, you need to somehow get that 3x minus 5 by itself. Well, remember, right now you're taking the square root of it. The opposite of square rooting is to square both sides, just like this. What you do to the left, you do to the right. And so the square and the square root undo each other, so you're left with 3x minus 5 is equal to, and then 3 squared, 3 times 3 is 9. So you went from this square root equation to this linear equation in this case. Solving this linear equation, we're going to add 5 to both sides, and 5 and negative 5 is 0, so you get 3x is equal to 9 plus 5 is 14. And then divide both sides by 3, you get x equal 14 thirds. Or if you want to write as a mixed number, you would say 3 and a 14. What's that? That's 4. 4 times 3 is 12. Subtract, you get 2. So you get 4 and 2 thirds. Okay, so either one of those is fine. Now, remember though, and this is going to be important here, remember though, when you raise both sides to an even power, which is what I did here, you may introduce, it is possible that you could have introduced extraneous solutions. And we talked about that. So extraneous solutions. And so extraneous solutions, kind of that idea of false solutions, a solutions that satisfies one part of the equation, but not the original. So notice that 14 thirds is a solution to and let me go ahead and do that here. So 14 thirds is a solution to this linear equation here. Well, I can just point to it. Is a solution to this linear equation, but the question is it a solution to the square root equation? Because whenever you raise both sides to an even power, you could introduce what's called extraneous solutions. Well, what we learned was that when I got the square root by itself, all I was left with was this constant 3. Remember, so we had right here the square root of 3x minus 5 is equal to 3. Well, there was no variable on this side. So there's no variable on this side and this number is positive, then you're good. As long as what you did was correct, this is a solution. All right, now some students, they will go back and check it. still. So to check, this is what you had to do. So I'm going to go ahead and check that here. So let's just check x equal 14 thirds. So to check x equal 14 thirds, you got to go back to the original, which is this. And where we see the variable x, you're going to substitute 14 thirds. So I get the square root of 3 times 14 thirds minus 5 plus 2. And I want to see if that's going to equal 5. Well, 3 times 14 thirds, the 3's divide out. So you get 1 times 14, which is 14. So this becomes the square root of 14 minus 5 plus 2, the left-hand side. Well, 14 minus 5 is 9, right? So that becomes the square root of 9 plus 2. And the square root of 9 is 3, and 3 plus 2 is indeed equal to 5. All right, but the point is that as long as this side here, that's on the other side of this square root expression, this radical expression, the side here, as long as that number is positive and it's not a variable expression, as long as you do this correct, you're good. Now over here, though, that's a different story because you have variables on both sides. So that's where we're going to have that problem. So you are going to have to check. All right, so let's look at number 9. Okay, so in number 9, notice I have the square root expression by itself. So now I'm going to do the opposite of square rooting is squaring both sides. So you're going to have to square both sides. So just like this, square both sides, square both sides. Notice that x minus 4 is inside this parentheses and is being squared. Okay, so now we're going to get rid of these parentheses. So x minus 4 squared, let's think about what that is. So x minus 4 times itself, right? So following this out, I get x times x is x squared. The outer, x times negative 4 is a negative 4x. Now remember, when you square a binomial, the outer and the inner are going to be identical. So you get negative 4x and another negative 4x. And then a negative 4 times a negative 4 is a positive 16. Combining like terms, I get x squared. A negative 4x and a negative 4x is a negative 8x plus 16. So that goes here. So that becomes x squared minus 8x plus 16 equal. And then over here, the square and the square root undo each other, so you get 3x minus 8. So notice I went from a square root equation to a quadratic equation. So I got to solve this quadratic equation. So I'm going to bring all the terms to the left-hand side to put it in standard form. I want 0 on that side. So I'm going to subtract 3x on both sides. I'm going to line my like terms, and I'm going to add 8 to both sides. So I'm going to do 2 steps in one. And now combining like terms, I get x squared. A negative x and a negative 3x is a negative 11x. 16 plus 8 is 24. Positive 16 and a positive 8 is a positive 24 equal. 3x minus 3x is 0. 8 and negative 8 zeros. I get 0 on this side. Now for us, this is going to be factorable. And so when I factor this, I'm going to get x, let's see, that's going to be plus, minus 8 and then x minus 3. So you can always check x times x is x squared. The outer is a negative 3x. The inner is a negative 8x, and you get negative 11x. And then a negative 8 times a negative 3 is a positive 24. And now we're going to set each of those factors equal to 0 using the zero factor property. And when I do that, I'm going to get x equal 8 and x equal 3. So those are your proposed solutions. And I'm calling them proposed solutions because those are solutions to this quadratic, but the question is, are they solutions to the square root equation? And so remember, that's where we have to check for extraneous solutions, because I did raise both sides to an even power. And the fact that I had variables on both sides, I do need to check. All right, so let's check each one. So we're going to check x equal 8. All right, so we go back to the original, and I'm going to rewrite the original. And where we see the variable x, I'm going to substitute 8. So I get x, which is 8, minus 4. And I want to see if that's going to equal to 3 times x, which is 8, and then minus 8. Well, 8 minus 4 is 4. Over here, this side, 3 times 8 is 24. So that becomes the square root of 24 minus 8. And then 24 minus 8 is 16. So this becomes the square root of 16. And the square root of 16 is 4. And notice those are the same. So x equal 8 is going to be a solution. Now let's check 3. Do the same thing. So x minus 4 equal the square root of 3x minus 8. So I already see the variable x. I'm going to substitute 3. So I get 3 minus 4 equal. I'm going to see if that's going to equal. And then that's going to be 3 times 3 minus 8. Well, 3 minus 4 is a negative 1, right? That's a negative 1. Over here, 3 times 3 is 9. So that's the square root of 9 minus 8. 9 minus 8 is 1. And the square root of 1 is 1. Notice 1 does not equal negative 1. So what that means is that this x equals 3 is extraneous. That's an extraneous solution. So x equals 3 is a solution to this quadratic, but it's not a solution to the original square root equation because 3 minus 4 is a negative 1, and a negative 1 does not equal this positive 1 that we saw. All right, so the only solution is x equal 8. All right, so that was number 9. Okay, number 10, you want to solve this linear inequality. And so remember, you're going to solve a linear equality just like you would a linear equation, except there are some properties you have to be aware of. So we're going to use the distributive property first. 3 times 2x is 6x. 3 times a negative 3 is a negative 9. And then over here, we're going to distribute the positive 2. 2 times x is 2x. 2 times 1 is 2. Less than or equal to 4x minus 3. Combining like terms, 6x and 2x is 8x. A negative 9 and a positive 2 is a negative 7. It's less than or equal to 4x minus 3. Bring all the variables to one side, constants to the other, since this is linear. We get 8x minus 4x is 4x. Minus 7 is less than or equal to, this is 0, and 0 to negative 3 is a negative 3. Adding 7 to both sides, I get 4x, this is 0, is less than or equal to 4. And then dividing both sides by 4, I get x is less than or equal to 1. So notice that any real number less than or equal to 1 is a solution to this linear equation. Now the directions indicated that you wanted to write this in interval notation. Well, in your mind, you know that on the graph it looks like this. So this is what the graph would look like. Here's 1. Since there's an equal sign, that means that 1 is a solution, so you're going to use a closed circle. And you're going to shade in every number to the left. And so in writing interval notation, you're going to go from left to right on this number line. So you're going, notice this arrow is pointing towards that idea of negative infinity. So you're going to say interval notation, you're going to say negative infinity all the way to this positive 1 with a bracket. So notice whenever you have infinity, negative infinity, always use parentheses. If there's an equal sign, equal to 1, you're going to put a bracket, closed circle relates to a bracket. So that's your solution in interval notation. So there's your work. This is what you have to tell me in interval notation. Number 11, you want to solve this compound inequality. So remember, compound inequality, you have more than one inequality symbol. And there are two approaches you could have used. The easiest approach is to isolate the variable in the middle. And so to do that, to get 4x in the middle, right now you're adding 2, so you're going to subtract 2 from all parts. Those are 3 parts here. And now combining like terms, a negative 5 and a negative 2 is a negative 7, is less than or equal to 4x, this is 0, is less than, and then 7 subtract 2 is 5. And then finally, and we go ahead and rewrite this over, to get x by itself, right now you're multiplying by 4, the opposite is divide all parts by 4. And so I get negative 7 fourths is less than or equal to, this is x, and that's less than 5 fourths. And so in interval notation, think about this in terms of a number line. So you're going from negative 7 fourths to a positive 5/4. So let's say this is negative 7/4 and this is 5/4. So since there's an equal sign in negative 7/4, that means that negative 7/4 is a solution. Since there's no equal sign here on 5/4, that means 5/4 is not a solution. But every real number between them is. So you have an infinite number of solutions. All these numbers, whether they're rational or irrational, is a solution. So in terms of the number line, you're going to go from left to right. So I'm going to go from a negative 7/4 with a bracket all the way to a positive 5/4 with parentheses. So make sure when you do brackets and parentheses, I can tell the difference. So if I can't tell whether that's a parentheses or a bracket, I'm going to not give you full credit. All right, but there's the work for approach number 1, and then there's the interval notation. So notice that's the most efficient way. The other approach that some students take is this. So what they do is they want to rewrite this in two separate ways. So notice when you read this, this reads as negative 5 is less than or equal to 4x plus 2, and at the same time, 4x plus 2 has to be less than 7. So I'm going to read that again. Negative 5 is less than or equal to 4x plus 2, and you have to use the word and at the same time, 4x plus 2 is less than 7. So if you wrote it like this, I did need to see the word and, because and here you're going to be looking at the intersection of those two solutions. And so we're going to solve each of those individually. So I'm going to subtract 2 from both sides. So I get negative 5 and a negative 2 is a negative 7 is less than 4x. And then dividing both sides by 4, I get negative 7/4 is less than or equal to x. Now negative 7/4 is less than or equal to x. It means the same thing as x is greater than or equal to negative 7/4. So most students prefer to write the variable on the left-hand side of the inequality symbol. Over here, subtract 2 from both sides. We get 4x is less than 7 subtract 2 is 5. Divide both sides by 4. I get x is less than 5/4. Okay, now, if you do it this way, in your mind, you have to be thinking like this. All right, so here's negative 7/4, and then here's 5/4. If I look at this first one right here, I need to shade in every number that's greater than or equal to negative 7/4. So remember, x greater than or equal to negative 7/4 is a solution to this inequality. It may not be a solution to the original. So that's why you have to look at this separately. So here's negative 7/4 with a closed circle because there's an equal sign here. And I'm going to shade in everything to the right. So any number shaded here is a solution to this linear inequality. Now I'm going to go here. X is less than 5/4. Open circle because there's no equal sign, and then shade in everything to the left. So any number that's to the left of 5/4 is a solution to this inequality here. Now, though, we got to find out, well, what is the solution to this compound inequality? That word and. That's why you have to show the word and. If you didn't show the word and, you would not get full credit. And so that's where we look at the intersection. So that's where those two graphs intersect. So that means then that the solution to the original compound inequality is where those two graphs overlap, where they intersect. So they intersect from negative 7/4 to 5/4. Closed circle, open circle, everything between. And so now you can write your interval notation. And so your interval notation is going to be from bracket negative 7/4 all the way to 5/4 with a parentheses. All right, so that was the second approach. Notice if you did use the second approach, and there are a few students that do, this is what you have to show. I need to see the word and, though, and you have to show some work. Okay, now in the last problem, you had this absolute value equation. To solve an absolute value equation, you want to get that absolute value by itself. Once you get the absolute value by itself, which is already by itself, so that makes things easier for you, then you're going to rewrite this as two separate equations without the absolute value bars. So you have to show this part here. So to go from this absolute value equation to two equations without an absolute value bar, you would say, and all you do is just, to the first one is easy, you just rewrite what you see here. So 3x minus 2 is equal to 5. Now remember, the absolute value, that distance that a number is away from 0. So on both sides of 0, so one's positive, one's negative. That's that idea here. So, and then the other one's going to be 3x minus 2 is equal to the opposite of 5. So notice, 3x minus 2 are both listed on the left, and then one's a positive 5, and then you do the opposite, which is a negative 5. And then you went from an absolute value equation to two linear equations. You solve the linear equation, and you're done. Now, I do want to say this though. If notice that this absolute value equation, you're going to have solutions because this number here is a positive number or 0. If that was negative, you would have no solutions because the absolute value of a number is never negative. All right, so that was discussed in some of those lessons. But the fact that this is a positive number, you're going to get solutions, so you break it down further. So then we're going to add 2 to both sides. So I get 3x is equal to 7. Divide both sides by 3. One of my solutions is 7/3. Over here, add 2 to both sides. I get 3x is equal to negative 5 and 2 is a negative 3. Divide both sides by 3. I get x to be a negative 1. And those are solutions because this is a positive number. And you can check, by the way, look, 3, let's check the 7/3. 3 times 7/3, the 3's divide out, that's 7. 7 minus 2 is 5, and the absolute value of 5 is 5. Negative 1. 3 times negative 1 is a negative 3. A negative 3 and a negative 2 is a negative 5. And the absolute value of a negative 5 is a positive 5, and that's what we wanted. All right, so that is it. So that is the key to version 1 of test 1.